Section 7a, graphing radical functions. Our objective is to graph radical functions. So in the last section, we talked about inverses. And if you were to find the inverse of x squared, you'd switch your x and your y's and you solve for y, and you'd end up with your inverse being plus or minus the square root of x. So this is the square root function that we are going to be graphing. And this is what the graph looks like right here. Now, the second thing we're going to do is we talked about cubic graphs. So if you were to, for this one, switch your x and your y, so you would get x equals y to the third and solve for y, now you have to take the cube root of both sides, so y would be equal to the cube root of x in this case, and that's where we get the cube root function, which is over here. So notice that it kind of looks like a sideways s. And also notice that we don't have the plus or minus in front because we're not getting rid of an even power. So let's first talk about our square root functions. Now, we're going to graph these on the same graph. Now, you can use your calculator to help you, but we're going to do the first one without our graphing calculator because it's not that hard to do. Remember, when we take the square root of a number, if it's not something that is positive underneath the even root, then we get imaginary answers. So if I look at this radical graph right here, if I try to do the square root of -1, I would get I. So I can't graph that. But if I go to the next number, 0, the square root of 0 is 0, so that starts my graph right here. The square root of 1 would be 1. The square root of, I would go to the next number, 2 is not going to give me a nice number. The square root of 3 doesn't give me a nice number, but the square root of 4 gives me 2. So I'm going to use that. And the square root of 9 is the next nice number, which gives me 3. So my graph is going to look something like this. And notice that it starts at some point and the other side continues on forever, because we can't have numbers that are below an x value of 0 in this case, because it makes underneath my radical an imaginary answer. So if we go to our graphing calculator, just to look at this, I graphed this first one. If I hit graph, and I guess I should hit zoom 6 for a nice standard window, this is what my graph looks like. And even just to show you, if I go to my table and look at my table values, notice that below 0 it says all errors. That's how I know that my x values are starting at 0. It's another way to tell. And also notice that I picked the nice numbers that I can take square roots of to plot them on my graph. So what we're going to do next is we're going to plot each of these and see what's happening to our graph. So if I put them into my calculator, y equals, and we can graph them all together by turning on these equal signs. And if I hit graph, notice that one was if I added 2, if I added 5, and if I'm subtracting. So notice that when we have numbers on the outside, it either moves our graph up or down from our parent function. So this would be our parent graph right here, y equals the square root of x. So that was the first one that we graphed in red. So the next one I'm going to do is this one right here. So I'm going to take my parent function and just actually count up 1, 2. So 1, 2, 1, 2. And so my graph is going to have the same shape, we just moved it up 2 units. So this translated it up 2 units. And this one right here was our parent graph. So for the next one, this one moved it up 5 units from our parent graph. So starting with a red, I'm counting up 1, 2, 3, 4, 5, which would be here. So 1, 2, 3, 4, 5. I'm just taking all the points that I had for y, 1, 2, and just counting up 5. So that would be my next graph. And then my last graph, we're subtracting 3 from my parent graph. So down 1, 2, 3. And my graph would look like this. And of course, you can use your graphing calculator to help you get that as well. So this one was down 3, and this one moved my graph up 5. So let's go ahead and make a conjecture. Describe the similarities and differences between the graph of y equals the square root of x and the function's graph number 2. Make a conjecture based upon those observations about y equals the absolute value, or y equals square root of x plus k. So k moves the graph up when it's a plus k, and down when it's minus k. And notice that what are we changing? We're changing our range values. And remember, your range values are all possible y values. So now let's do the next part. Notice the difference between these and the ones we just did is that that number is now underneath the radical instead of being on the outside. So in my calculator, if I go to my y equals, we already have the first one, but instead of being the square root of x and then plus 2 on the outside, we need it underneath the radical. So in some of your calculators, you have to put parentheses. If you have a newer calculator, it does it underneath the radical for you. So most of you will have to probably do parentheses, which your calculator normally does that automatically. So parentheses x minus 2. And that tells me that everything is underneath the radical and I can see it above it. So those of you who have an older calculator, again, make sure you have those parentheses put there to tell that it's underneath the radical. So for the next one, do the same thing. So now that I'm at equations enter, if I hit graph, I see there's my parent graph. I first did minus 2, minus 5, and then this one out here was plus 5. So I'm going to graph all these. And remember, you can go to your second graph and use your table in order to help you do that and pick nice values. So the first one's easy because the first one is my parent graph. So I'm going to go ahead and graph that in red. So I have 0, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is equal to 3. So that's my parent graph. Now for the next one, when we did minus 2 underneath the radical, notice that that's changing your x values now. So if I go back to my graphing calculator, and I'm going to go to my y equals and turn off these other graphs besides the x minus 2. Just to show you, so I can hit those enter on the equal sign to do that. So if I go to my table and look at this graph, notice that we have error. Where do my values for x start? They start at an x value of 2, and we have numbers beyond that. So we literally took this graph and moved it to the right 2 when we did x minus 2. So we took all our values and did 1, 2 here, 1, 2. So I'm moving all my x values to the right 2, and this gave me my next graph, which was x minus 2. So this moved it right 2, and for the next graph, now we're moving this one to the right 5 from my parent graph. So I'm taking the graph in red and I'm counting to the right 5 units. The graph would look like this. And then the very last one, we're moving it to the left 5. And notice that for this, the plus moves it left, so it's opposite thinking that you normally would, and the minus moved it to the right. So be careful when you see that. A lot of students end up accidentally messing it up like we did in the other sections. So left 1, 2, 3, 4, 5. And we get our graph. Now notice that we moved our graphs to the left or to the right. So in this case, now the last one we were changing our range values. This one's changing the domain values. And remember, domain values are your x values. So when it's underneath the radical, it changes the x. When it's on the outside, it changes your y. So let's actually go ahead and write down the domain and range for each of these functions that we have. So remember that the domain is all possible x values. Well, where did our x values start? How do I know? I look at the radical that I have. And remember that underneath the radical has to be greater than 0. So the way that I can do this, I can take what's underneath the radical and set it greater than or equal to 0. Because if I plug in 0, we said the square root to 0, 0, but anything less than that gave me imaginary answers. So I know that my domain, and you can even look at your graph, your x values start here and they're going to the right. So we have x values greater than or equal to 0. And I know that my range values then are starting at here and going upward. So my range values are going to be y is greater than or equal to 0 because they're positive. Now if I go to the next one, I have plus 2 to my equation. So if you look at this one, notice that your x values are still starting at 0 and going to infinity. So my domain here would be as x is still greater than or equal to 0 because that's what's underneath the radical. My range in this case, however, changed because I moved it up 2 units. So now I know my range is going to be y is greater than or equal to 2 instead. For the next one, we have this graph here, my domain values, notice that x is the only thing underneath the radical, so still x is greater than or equal to 0. And my range values, we're moving our graph up 5, so y is greater than or equal to 5 in this case. And then for the very last one, our domain, still x is greater than or equal to 0. And again, you can tell by looking at the graph, all your x values for each of these graphs start at 0 and go to infinity. And then my y value was moved down 3, but we still have values greater than that. So y is greater than or equal to -3 in this case. So those are my domain and range for each of these. So remember, your range values go this way, and your domain values go this way. So then for the next graph, let's do the same thing and write down the domain and range. So I know what A, because that's our parent graph, our domain still has x values starting here at 0 and they're positive, so x is greater than or equal to 0. My range in this case, I did not move my y value up or down, so my y values start again at 0 and go to infinity, so y is greater than or equal to 0. For the next one, now notice that underneath my radical, I have x minus 2. So if I take that x minus 2 and set it greater than or equal to 0, that's how I can find where my domain values are starting. So add the 2 to the other side and you get x is greater than or equal to 2. So those are my domain values because look at here, we're starting at 2 and we're going all the way this way for our x values. So the way that we would write that for domain in this case is x greater than or equal to 2. And remember, we can even use our graphing calculator to help us see that that's where our x values start, because notice that any x values below 2 just say error and they don't start until 2. So you can use your calculator as a tool to kind of help you see that. And even if you go to your graph and you hit trace on your graph, you can confirm if you look at your x values that are below 2, notice that there is no y value there. And we don't get a y value until we get to an x value of 2. So that's another way that you can tell that that's where your domain values start. And to tell what your range values are, you can also use your calculator table. So if my x values start at 2, where do my y values start? Well, in this case, they start at 0, and I can do that for all of the graphs. So that's another way to tell your range. So my range in this case, I didn't move my graph up or down at all, so y is greater than or equal to 0. For the next one, my domain, we take what's underneath here and set it greater than or equal to 0. So in this case, x is greater than or equal to 5, so our x minus 5, sorry, is greater than or equal to 0, so x is greater than or equal to 5 when we solve. If we were dividing by negative there, of course, you would also have to flip your inequality sign. So I have x values greater than or equal to 5, and then my range, our y value is greater than or equal to 0 because, again, I didn't move my graph up or down. I just moved it to the right 5. And then for the last one, my domain, take what's underneath the radical. So I have x plus 5, set it greater than or equal to 0. So x is greater than or equal to -5 in this case. So my domain values are x is greater than or equal to -5. And my range values start at 0, so y is greater than or equal to 0. So you can look at the graph or you can look at the equation to kind of help you figure out what the domain and range is going to be. So remember the two red flags we have for domain, variables that make the denominator 0 or variables that make underneath an even root negative. And so that's why I took what was underneath the radical and set it greater than or equal to 0 to find what my domain was going to be, or I looked at my graphing calculator. So it says, describe the similarities and differences for the last graphs that we were doing based upon if we had y equals the square root of x minus h. So that h value is going to move our graph to the right or to the left depending on what it is. So if we have y equals the square root of x minus h, our graph moves right. And if our graph is instead y equals the square root of x minus negative h, which would be plus h, we know we're going to move our graph to the left. So the next one, it says on the same coordinate plane, we're going to graph the following functions. And notice instead of moving our graph left or right or up or down, we're changing this value that's in front. So my parent graph is the first one, which we should know what it looks like by now. Start at 0, 0, 1, 1, 4, 2, and 9, 3. So that's this graph right here. So you should be able to graph that one without even using your calculator. And for the next one, we are going to do 3 times x and then 0.5 times the square root of x, and then for d, we're doing -4 times the square root of x. And think about what we did with our quadratic graphs. When I had y equals x squared versus y equals -x squared, think about what happened to the graph and see if you can conjecture what's going to happen with that negative in front of our radical that we have here. So I plug these in my calculator and I'm going to hit graph to see what they all look like. So that's my first graph, my second graph, third, and last graph. So notice that that negative that we had ended up being this graph right here, so it reflected my graph over the x-axis, so it makes it open downwards or go downwards. When this one right here is my parent graph, the y equals the square root of x, when we had the times 3, notice that, oh sorry, and that's actually not my parent graph, I did the wrong one. This one's my parent graph. When I did the 3, notice that it makes my graph look larger, so this stretches it vertically by 3. So this was the y equals 3 times x, and then notice that when I have 0.5 in front, it makes it look smaller than my parent graph. So it's called a compression by 0.3 is what we use for that value right there. So let's go ahead and in order to graph these, you can use your table. So if I go to my table in my calculator and I take a look at these,